Welcome to Lecture Online. Our third set of examples deals with rational expressions. A rational expression is where we have fractions, we have a numerator and a denominator, and we need to simplify that using the rules of operations. Now when we have a numerator and a denominator, we want to work out the numerator separate from the denominator before we finally then divide the numerator by the denominator. Let me show you what I mean with that. In this example, we're going to simplify the numerator until we get it down to one number, and then we're going to simplify the denominator until we get it down to one number, and then we're going to do the division. Okay, first we want to get rid of the parentheses. This becomes 5 times 4 minus 1 is 3, plus 3 divided by, and here we could already do 2 times 4. 2 times 4, that's 8 plus 1. Next, we can multiply this. 5 times 3 is 15, plus 3 in the numerator, divided by 8 plus 1 in the denominator. That gives us 9. Now we can add the numerator. 15 plus 3 is 18, divided by the denominator is 9, and 9 goes into 18 exactly 2 times, and that's the answer. So notice we followed the rules of operation for the numerator separate from the denominator. In the numerator we had parentheses, we got rid of those first. In the denominator we had a multiplication and an addition. We took care of the multiplication first before we did the addition. Let's take a look at this one over here. Again, in the numerator we have parentheses, we'll take care of those. In the denominator we have a multiplication and an addition. We'll do the multiplication first. The numerator then becomes 7 times 3 plus 1, which is 4, minus 2, divided by 5 times 2 is 10, plus 3. 7 times 4, that's 28. I'll put an equal sign there. That's 28 minus 2 divided by 10 plus 3. I could have done the addition already, but we'll do that next time. 28 minus 2 is 26. 10 plus 3 is 13. 26 divided by 13, that one is also 2. Let's go on to this one here. Notice we have parentheses, we have a multiplication there. We can do this as follows. This is equal to, first we add what's in the parentheses, 2 times 5 plus 3, which is 8, plus 2 times 2, which is 4, divided by 2 times, well, we have to do what's in the parentheses first, so this would be 2 times 4 minus 1, which is 3. Now we can do this multiplication here, we can do this multiplication there, 2 times 8, that's 16, plus 4, divided by 2 times 3, which is 6. And 16 plus 4, that is 20, divided by 6. And, well, 6 doesn't go evenly into 20. We can either leave it like that, or we can write it as a decimal. Before we do the division, we realize that they're both even, so we could write it as 10 divided by 3. And then I can come over here, and 10 divided by 3. 3 goes into 10. 3 times 3 times 3 is 9. Remainder is 1. Have a decimal point there, add a 0, drop the 0, 3 goes into 10, 3 times 3 is 9, and you can see the pattern right away that it looks like it's going to be 3.333 and so forth. So we could write this as 3.3 with a line over it, indicating that 3 will go on indefinitely as a decimal. Finally, let's look at this one, and let me draw a line in between here so you can see that those are two different problems. Again, we want to work the parentheses first and the multiplication first. So the first thing we do is 9 times 7 minus 1, which is 6, minus 8 times 2, which is 16, divided by 4 times what's inside of parentheses, which is 5. Next, we can do the multiplications. 9 times 6, that's 54, minus 16, divided by 4 times 5, which is 20. 54 minus 16, that would be 38 divided by 20. They're both even, so I can simplify that. This becomes 19 divided by 10. And 19 divided by 10, if I move the decimal place over 1 and move this place over 1, 19 divided by 10 can be written as 1.9. And that's the final answer for that one. Again, that's how you deal with the order of operations, especially when we have rational expressions. We have a numerator and a denominator. You want to work those out separately before you do the final division like that. And that's how that's done.